Welcome to the first lesson on circles. This lesson is very, very heavy on vocabulary. And in fact, it's the whole point of this lesson is to get some basic vocabulary in our toolbox so that as we learn about circles, we're all discussing the same thing. So our essential question is, what basic vocabulary do I need to know? All right. To begin with, let's define a circle. A circle is a set of points that is equidistant from the given point called the center. And I'm going to label that center point C. All right. There are 360 degrees in a circle. When we want to abbreviate a circle, we use a circle with a dot in the center so that we can tell the difference from a zero. All right. And if I wanted to name this circle, I would use the symbol for circle and the letter for the center, whatever letter was used. Now, this is a vocabulary word, so we're going to highlight it, and you are going to make me a note card. You're also going to make me a note card here and a note card here. So I'm going to highlight while I've got the highlighter out. All right, a segment with endpoints at the center and on the circle, and I'm just going to call that point D, is called the radius. All right, we do use a lowercase r to represent radius. Okay, but there's no shortcut for that other than the lowercase r. If you are a segment with endpoints on the circle, let's say A and B, you are a chord. Notice that this example did not go through the center of the circle, okay? And we would write this as segment AB. Next up, if we have a chord that specifically goes through the center of the circle, we're talking about a diameter. All right, so through the center, still going to call that center C. Let's call these endpoints A and B. The diameter is equal to twice the radius, right? So diameter equals 2r, right? AC is a radius, CB is a radius, and this entire thing is a diameter. And we use a lowercase d for diameter. Yet another vocabulary word. All right. A line that intersects a circle in exactly 2 points is called a secant. All right, let's do. A line has arrowheads, remember? Sometimes in diagrams, those arrowheads are not shown. Okay, but we actually cross through the entire circle and intersect in 2 points, and this, of course, would be line AB is a secant. If we intersect a circle at exactly 1 point, for example, 1 point, this is called a tangent. We've seen the word tangent before in the right triangles unit, so this is an example of the word tangent being used multiple ways, similar to how we use the word range multiple ways in mathematics. All right, and this, of course, would be line AB. point of tangency. Okay, this is the point at which we actually intersect the circle. So, oh, I forgot to put a center on my circle here. In this case, point A is my point of tangency. And yes, we need a note card for that. Next, a few more vocabulary words. I'm going to go ahead and highlight on this page before I do the notes. Just a little easier while I have the highlighter up on the smartboard. Okay, so let's talk about some different types of angles. An angle with the vertex on the center and sides that are radii. So this would be A and this would be B. So here I'm talking about angle ABC. This is called a central angle. If the vertex is at the center, it is a central angle. Okay, so at least the definition ties into the vocabulary a little bit. An angle with the vertex on the circle and sides that are chords. So A, B, C, and I guess I will name this circle P. So angle ABC. We call this inscribed. An inscribed angle. Vertex on the circle. A portion of the circle defined by two endpoints. All right, so let's have circle P. If I want a portion of the circle, I want this. This is called an arc. And our symbol mimics what it looks like. It's a little baby arc. So I would say arc AB. Just like with lines and line segments, you read the symbol on top first. Make sure that it's curvy symbol, pointy, like this, has a completely different meaning mathematically. So you definitely have to curve it. Don't let it look straight either, otherwise it looks like you're talking about a chord or a line segment. Now we do have different types of arcs. We have minor arcs. Ooh, I'm in highlighter. A minor arc has a measure of less than 180 degrees, and you must name it with two letters. So let's have circle P again. I'm going to put M and N just because I'm tired of A and B. MN is a minor arc. We also have major arcs. And a major arc has to be named with three letters. Okay? It has to be greater than 180, but less than 360 degrees. So if I'm talking about this arc, definitely more than 180, this would be major arc ABC. Okay, so you have to start with whatever the beginning point is, whatever point you go through, and then you end up with whatever point you land on when you name it. If I said arc AC, the automatic assumption would be the minor arc that's in that diagram. So without three letters, whoever's looking at your work thinks you're talking about an arc measuring less than 180 degrees. All right. Our last possible option is an arc that measures exactly 180 degrees. And that means, oh, let's do RS. If it measures exactly 180 degrees, we're talking about a semicircle. If your arc measures exactly 180 degrees, you are talking about an arc whose endpoints are odd diameter. Okay, and it can be named two ways. You can just use two letters, because it doesn't matter whether I go around the top of the circle or the bottom of that circle, it still measures 180 degrees. We could name it with three letters if we wanted to. Okay, but it's not necessary for a semicircle. Shifting gears here with the vocabulary. And, whoa, where'd that go? There we go. Okay, a point that lies on the inside of a circle. Let's see. So let's see point Q. We very cleverly call that an interior point. And when we have a point that lies outside of the circle, we very cleverly call that an exterior point. Still not done with the vocabulary, ladies and gentlemen. A line that is tangent to at least two circles. Tangent, we're going to intersect in one point. So let's see how well I can draw this. There we go. One point to each circle. Let's make this one P. I'll make this circle Q. And let's make these points M and N. So tangent MN is called a common tangent because it actually intersects with two circles. It's actually tangent, to two separate circles. Now we have some specifics with common tangents. A tangent line that passes between two circles. So let's do P and Q. And I need to be tangent to both. I'll make this M. I'll make this N. Okay. I know it passes between two circles. If I connect the centers with an imaginary line, this tangent actually intersects that imaginary connection between the centers. When this happens, it's called a common internal tangent. Okay, and it must cross this imaginary line. So I'm going to draw this in. Must cross imaginary line connecting the centers. Okay, so what happens if it does not cross an imaginary line connecting the centers? And I'm going to go ahead and write that in. Does not cross. Alrighty, let's draw this in. P and Q. Here's our imaginary line connecting them. If I have a tangent that does not cross that line, well, it's a common external tangent. All right, one more word. One more word, which is kind of nice because we've got an awful lot of vocabulary in one lesson. And that is concentric circles. Concentric circles are two or more circles with the same center. Okay, I could be talking about that small circle P or the larger circle P. If you think of a bullseye, those are good examples of concentric circles. So let me count here real quick. 3, 7, 11, 15, 19 vocabulary words in this lesson. I'll say that again. 19 vocabulary words in this lesson, and you need to make note cards. All right, let's actually practice some of this vocabulary. That would be useful. We have this beautiful diagram here, right? I have circle O, which is the really big circle. I have circle P, which is the small circle. I've got all kinds of chords and lines and angles going on. It's kind of fun. Let's name DBE. Start at D, go down to B, come back up to E. Okay, that's an angle, and my vertex is on the circle, so it is an inscribed angle. Let's look at DB. Well, DB is already marked up here for me. D starts on the end of the circle, comes through the center, and ends on the other side of the circle. So that's a diameter. Next up, we have segment AB, right? Segment. Now, that's part of a line. If I was looking at the line, I'd be talking about a secant. But because I'm talking about a segment that starts and ends on the circle, this is a chord. A chord is part of a secant. And the next one asks about line AB, which I just talked about as being a secant. What do we have next? Line EC. Whoops. Okay, let me bust out another color here. Line EC. Here's E, here's C. Wow. Okay, it touches at one point, that makes it a tangent. Touches at one point, that makes it a tangent. If I connect the centers with the imaginary line, it does cross that imaginary line, so that is a common internal tangent. Angle DOE. Okay, let's see. I'm going to pick up purple. Angle D to O to E. All right, O is the center of that angle. That makes this a central angle. And arc DA. Let me pick up yet another color. I don't know. How about orange? Let's come arc DA. All right, so is that less than 180 degrees, equal to 180 degrees, or greater than 180 degrees? It's less, so this is a minor arc. And finally for this diagram, segment OE, picking up yet another color. Why don't we go bright green? Oh, we've used OE before, but we'll go over it in bright green. That looks like a radius to me, ladies and gentlemen. It starts here at the center, and it goes to one side of the circle. So we're talking radius. That green almost looks like the highlighter, doesn't it? Interesting. All right. On the next page, I copied the same diagram because we haven't used very much of it yet. And I'm continuing on with the questions. Point P. Point P is a center. Alrighty. Arc DEA. Arc D. Start at D. Go through E. Come all the way around this circle to A. Less than 180, equal to 180, or greater than 180. Definitely greater. So this is a major arc. Arc DAB. I'm going to pick up a highlighter for this one. Let's go blue. Start at D, go through A, end up here at B. Is that less than 180, equal to 180, or greater than 180? Happens to be equal, so this is a semicircle. Probably writing in highlighter was not my best idea. Semicircle. What's next? 12, BF. BF. All right, here's B, here's F. B is a point of tangency. F is a point of tangency. So this is a common tangent because it connects two. If I do that imaginary line between the centers, it does not cross that imaginary line. So this is a common external tangent. All right, point E. Point E, where are we? Ooh, point E, pick up the yellow highlighter here. Let's see, point E is on a chord, but we don't have a special name for that. It's also on a radius, we don't have a special name for that. But point E is on line J, I'm just going to kind of dash this, JEC, and that is a tangent line. So a single point on the tangent line and on the circle is called a point of tangency. HJ looks to be our last one to identify for our notes today. HJ, let's see, here's H. Here's J. What in the world do we have? Ooh, I'm touching the circle in one point. That makes it a tangent line. It only touches one of the circles, so it's just a plain tangent. Okay, for your summary, right, there are 19 vocabulary words. I want you to tell me which of these words you did not already know. I figure you probably knew 5 or 6 of them to start, but the rest of them were most likely new.